Right. Good afternoon, everyone. My name is Leijun Yin. I'm the senior photonics engineer from Optilab. Optilab is a fiber optics company. We're located in Phoenix, Arizona. We specialize in providing all kinds of photonic solutions. The optical sensing system are developed in our subgroup called Sedona Photonics. Sedona is a beautiful place in Arizona. If you have a chance, you can stop by. So today I'm going to present you the Oak Creek photonic sensing solution. This system is based on IoT, Internet of Things architecture. In IoT, there are a lot of sensors. They can be of different types, temperature, strain, whatever, but they are all made based on optical sensors. And then we have detectors and other like DAQ system integrate in our unit called Sedona. This unit also serves as a gateway device to pre-process data and then push data out to the cloud. In the cloud, there's an electric software hosted there, which does post-data processing and then distributes the data and useful information to the terminal user. This entire system can be used for both structural health monitoring and condition monitoring. So there are different kind of sensors. One specific sensor we developed for this system is a fiber accelerometer, still based on FPG. This sensor we call the Pebble. It's highly reliable because it's thanks to its hermetic sealing and there's 3mm armor cable installed in it. You see, we build very tough stuff that's really ruggedized and you can't break it. Also because it's highly sealed, so you can even use it underwater. For FPG sensors, there are two ends. You can see that there are two ends and it can be cascaded. So you can put multiple sensors there to detect XYZ vibration. The key component in this system is called FPG interrogator, which interrogates the FPG wavelengths and further convert to physical quantities. This Optilab developed very special products which can differentiate us from other products, which is a portable interrogator. This thing is a battery powered. You can run it for over 3 hours. And there's a 7-inch touchscreen display there. It also has built-in Wi-Fi. So all you need to do is just plug in your sensor, power on, then the touch screen is going to display all the data, plots the waveform, it even does FFT. So you don't need a computer. You just carry it on, go to the site, plug in, that's all. In addition to the hardware, we also developed some software. It's a multiple platform, cross-platform system. We have both Linux, Windows, and embedded system. For IoT capabilities, we do pre-data processing and also does data compression, so you don't have to send too many data to the cloud. You only transfer the data that's really useful. Can help you to reduce the data traffic. We're also working on the cloud analytic. So next I'm going to show you a video of how this system works. So here's the main screen, main home page. First we start from the wavelengths, the time domain data. There are 4 channels built in this system. You can switch between different channels. Each channel supports up to 8 sensors. So you can choose to display all 8 sensors at one time, or you can just choose to display several sensors you are interested. Also, it comes with like a auto center function, just like so you don't have to know exactly what's the wavelength of this sensor. So you will auto detect and center it to screen, and it will display on the right hand side on here. The entire operation is very similar to the electrical oscilloscope. So you can zoom in, zoom out to the Y and X axis. Right now we switch to channel 1. There's that's optical accelerometer. You tap it, that's the signal you see. You can see the noise level is about like less than 1 picometer. And next we are going to use a jigsaw to vibrate a table. Here you see that's a pulse train detected by the accelerometer. So, and you can see the division. We zoom in time scale, now it's a 10 millisecond division. So this thing is running at 10 kilohertz. Besides that, we also have FFT function built in. Because this thing is running at 10 kilohertz, so we can sense up to, in the frequency domain, we can detect up to 5,000 kilohertz. Here it's zoomed in so to 500 hertz, so you can see the signal clearly. Now, you can configure different sensors. So there's a configuration page. For each sensor, you can designate as a different sensor type. For example, acceleration sensor, temperature sensor, strain sensors. If you choose a sensor, say this is an accelerometer, so you can type in the sensitivity there. For example, you type in a number, like for example 30, 35 picometer per G. Then enter that, you save it. Then you go back to the FFT. And now on the y-axis here, it's no longer shows in picometer wavelength change, but indeed it shows you how many G has been detected. So right now we scaled into like 0.1 G per division, and noise level is pretty low. Then we excite it. You'll see some signals there. Right, that concludes my presentation. If you are interested in our system, please come by our booth. Thank you very much.
Thank you very much. Thank you very much.